Alright, so we've got our scene. I opened up the preset for clouds inside the Pyrocluster folder inside the Advanced Render Example Scenes. And it's a pretty simple scene. We've got a sun, sky object with a material applied to it, our environment and emitter with our volume tracer and Pyrocluster material. These two are actually all we need to get started with the Pyrocluster scene, but they added a sun, a camera, and a sky just to give it some light and something to actually give it some shadow. So let's just render it out to the picture viewer, see what it looks like and how long it takes to render. Right away we can see that the volume, the shadow maps, it's taking a little bit of time to render. There we go. And I think we're probably going to get somewhere around maybe 2 minutes for this. So I'm going to pause the render and then we'll see the final result. Okay, so we've got our render. It actually took 3 minutes, 3.5 minutes, probably because I'm recording, but even though that's a little wide to render for a pretty small image. So let's look at our materials and settings to see how we can improve not only how fast it renders, but how the clouds actually look. If you look, you can see the edges are kind of blooming out, and you know, it's not, the edges of our volumes aren't actually as crisp as I'd like. You know, I guess you could say they almost look cartoony, but let's just go into our settings and see how we can get that really crisp cloud-like appearance and a little bit of a faster render time. So the first thing you should look at if you're trying to reduce some render times is the volume tracer of our environment. And the clouds preset actually comes with its own custom settings inside the volume tracer. But if you click on the render mode, you can see there's 3 presets: crispy, crispy gas, and hazy, with crispy having the best quality, longest render time, and hazy having the lowest quality, highest render time. So let's just switch to hazy, just a preset, and see how much quicker this renders out, and also how much more different it looks. You can see right away that it's rendering the shadow maps a lot faster. See, it's already done. So I'm going to pause the render and we'll compare the render times. Okay, as you can see, it took almost a third. Actually, it took less than a third of our first render, but you can't really see that much of a difference. But if you look closely, we get a little bit of artifacting towards the edges and our shadows. You can see some gradation happening. See the lines, and you know, it's not the best quality. What we're going to try and achieve is we're going to change our actual cloud material a little bit, at the same time keeping almost the same amount of quality but cutting our render times down. So let's go back into our volume tracer and let's talk about what all the settings are. Let's go into the custom user settings, and the first thing you'll notice are the world, shadow map, and ray trace step sizes. These basically define how far our scene is going to be subdivided to look for rays to actually define our volumes. That's actually where this is actually where you should look first if you want to increase or decrease your render times. So a higher value it won't subdivide as much, but again, you're going to get some artifacts inside your volumes. Let's actually turn these really high, turn these to 20, and see how much faster we render, but also how our quality decreases. You can see how fast that happened, but right away you can see our Pyroclusters don't even have the same form that they had before. I'm actually not going to pause it. Let's just see how quickly it renders. Almost done. Okay, as you can see, we did lower our render times even more, but our clouds do not look good at all. They're really flat, and the edges are really smooth. You don't really get the sense of volume looking at it. It actually looks more like an iceberg or something like that. So we have to find a way to balance our settings at the same time not losing so much quality. So let's do the volume tracer again, and we know that our shadow maps took the longest time to render, so we'll keep those at 2, but we'll bring these back down to 1. The ray trace step size actually isn't going to affect our scene at all because it only affects hard shadows and we only have soft shadows on our only light source. So these two settings aren't affecting our render time at all. But we also have the ray transparency limit, the shadow map transparency limit, and the ray traced transparency limit. Usually when Cinema 4D is rendering out a volume, it keeps doing its calculation until the transparency is at 0 for the edges. We can cheat a little bit by telling it to stop at, say, 10% transparency, which is what we have over here. And again, the shadow map transparency limit and the ray trace transparency limit only affect the soft shadows and the hard shadows. So we can cheat by telling Cinema 4D to not go so far as to calculate 0% transparency. So we can say maybe 8% transparency for the ray transparency limit, and let's just leave these shadow maps at 10. Again, we noticed that was what was taking longest to render. So let's just render out again and see what our settings, if our settings are the correct balance. Again, you saw how fast the shadow maps rendered out, and it does seem like we're going to go at a little bit of a quicker pace than 3.5 minutes. But again, I'm going to pause the render, pause the recording, and we'll come back when it's finished rendering. Our render's finished, and it looks pretty good. I mean, we've got a little bit of artifacting, but we cut our render time down to 1 minute 9 seconds, and the quality's pretty good. We found a sort of middle ground between our initial settings and the hazy preset. So I'm happy with how fast it's rendering, but now I actually want to change the look of our clouds. And for that, we need to go into our actual Pyrocluster material. And we've got a couple settings right off the bat. For example, let's just turn on a preview, which opens up and it renders out a single puff of our volume. Let's just switch the render mode to video post, which is an alternative. It renders much faster, but as you're going to see, the results are less desirable. They kind of almost look like when we had our world and shadow map step size is really high. Again, the world step size and ray transparency limit are really the first place you want to look if you want to decrease your render time. I wouldn't go looking at our Pyrocluster material if we want to decrease our render time. That's mostly the volume tracer's job. So let's switch that back to atmospheric, which is what we're going to be working with in the tutorial. And we've got a pretty nice render, but again, the edges are really self-illuminating a lot. It's burning out almost to white. So one of the first things we can do is turn off illumination. With illumination, you can control how much the puff illuminates even in the absence of light. So if you turn self-illumination up, even with no lights, again, you can see it'll illuminate itself. But it's really not what we're looking for the look of our clouds. So let's talk about the settings, then we're going to turn it off. We have diffuse mode, which is just your basic diffuse model and the self-illumination. Again, if we turn that up, it'll illuminate itself even in the absence of light. Let's just turn that back down to 0. And we have the transparency illumination, which helps illuminate our edges. For example, if we only had our Pyrocluster being illuminated by one light, but let's say we have global illumination on, the edge of our pyroclusters may look black because they're in shadow, but if we turn up the transparency illumination, we can balance it out and it'll look more natural. You also have the ray angle illumination, which basically it's now affected by the point of view of the camera. You're mostly going to be using diffuse illumination, but if you want the illumination to be affected by what angle it's facing, you can turn it on to ray angle. You've also got bump, which you can use to get almost a rock look. Shininess, you can control the overall glaze of it. Let's just reset that, reset the default. Soften can help blur it out. You can let's reset that back down to 0 as well. Let's reset that to default again. And our strength and bump, which, just like in a regular material, when you have bump on, you know what strength does, and our bump, let's just turn that up so you can see what effect that has. Let's turn that way up. Okay, you can see how that affects our puff, but let's just turn it off right away. That not in the single puff, but more in our actual pyrocluster. If you turn it on, set that to diffuse, you can see it's almost being washed out, but if we turn it off, we're getting some of our color. Okay, so let's go back to globals. The volume can affect the actual shape of our volume. We have luminosity, which when we turn that up, looks like illumination, but let's turn that back down to 0. Again, we don't want our material being washed out. Density does, in a way, control the density of our pyroclusters, but what it actually does is controls the overall opacity of it. So even if you have the density up to, say, something like 100, you're going to need the right amount of particles to actually show this. But again, remember how we said our clouds are looking a little dense? Let's turn the density down to 20. We can play around with it, if we don't like the look of it when we render it out. Coming down to color. This is pretty basic. Let's open up a preview again. Actually, maybe it'd be better if we just worked with a new pyrocluster material. So make a new pyrocluster material. We've got our basic material. It actually has age effects on. Let's turn that off. Okay. And if we set the left side of our gradient to red, you're going to see the inside of our puff turn red. There we go. And the edges are white. If we just move that in a little bit. Okay. So the edges of our pyrocluster puff are using the right side of our gradient, and the inside is using the left side. The gradient modes, we've got local radius, which will scale with our puff. So if our puff scales up, the gradient will also scale. But if we set it to flat radius, you can see it just stays the same size throughout. Let's turn on age effects, color mix. Let's just make sure it doesn't use the age color, but rather the just the color over here. So if we scrub through, you can see our gradient is not scaling with it, but let's turn that to local radius, and you can see our gradient scaling with the puff. World radius also scales with the puff, but it's based on screen coordinates. So the scale of our scene will affect what color our puff is. But let's just switch that back to local radius. You can control the minimum and the max. So if we turn the minimum up, our entire puff will almost be the left side of our gradient. And if we turn our maximum up, we get more of our white. Whoops, let's reset that to default. Okay. See, we also have the density. So our densest portions, our gradient will be controlled by the density of that area. As you can see, the red is now controlling more dense parts, but by default the left side controls the least dense parts and the right side controls the maximum density. We also have use intersection. Let's just make a new scene so you can see this, because this is actually really useful. Let's create a new Pyrocluster. Let's just switch it down to hazy. We just want to render it really quickly. Get a emitter out. Okay, let's create a box. Let's just extrude out, then extrude down. So if we move that up, rotate our emitter, move it up also. Okay, so let's also create an environment, put our Pyrocluster volume tracer on the environment and our actual Pyrocluster material on the emitter. So if we add a light, give it some soft shadows and render, you can let's just move ahead in our emitter. Let's see. Birth rate editor, 200. Speed, let's turn that way down, 100. Okay. Okay, there we go. Let's just wait until we've got enough particles. Okay, pause, and let's render. It's gonna go straight through our box. And there you go. But if let's actually cast shadows, self shadows. If we turn on use intersection, you're gonna see, the default settings are pretty good. You're gonna see it staying inside of our container. Well, we crashed there for a second, but we're back, and let's actually render this out to the picture viewer. I have our Pyrocluster material with use intersection on, and you can see it's actually staying inside of our box. But if it wasn't, you could use the ray bias. Turning it up actually makes it less sensitive, and it'll actually go outside of our box. So the default settings actually work pretty well. Alright, let's go back to our main scene. Alright, and we're done with globals. We actually have 3 tabs that we're not going to be using, which are the age, distance, and cylindrical distance tabs. And I'm just going to explain what they do and what you can use them for. The age effects affect how our particle changes from birth to death. Inside of our emitter, we can actually set the lifetime. On this emitter, it's set to 1,000 frames. So over 1,000 frames, our puff's appearance will actually change. Let's just scroll through on the preview, and you can see our puff changing throughout its lifetime. And we can affect the radius. Black would set the beginning radius to 0. The left side of the gradient is birth, and the right side is death. So if we just reload this, you can see we have a radius of 0. If we set it to white, our radius is 100%, which is 100 centimeters, which is what we the default inside of a new Pyrocluster material. We can also, let's just change this to black, so as it goes through its lifetime it actually gets smaller. We can also affect the luminosity. We don't actually have any on, but let's set that up to 100%. And for age, let's actually set it so it doesn't have luminosity until halfway through its lifetime. So from the beginning we have no luminosity, and as we scrub through its lifetime you can see the luminosity getting slowly to 100% and then going off, because we have the birth also set to black. We can mix between the color set in globals and the color set in the age tab. So let's just set this to green, and let's say it starts changing color immediately from black from birth to death, and you can see our material changing. Let's actually set that to local radius. Alright, there you go. You can see our material changing from black to green. If we actually turn radius off, okay. You can see it turning from black to green, but you're also noticing that it's going transparent. Now if we go into our color mix, we have some new options not seen in the other gradients, namely Edit Alpha. So if we turn that on, you can see that from birth to death it has 100% alpha, and then it slowly wanes off into black. If we set that to white, you're going to see our material not fading off. But usually most Pyroclusters you're going to want it to actually fade off and become transparent. Otherwise, when it hits death, it's just going to disappear, and you don't want that. Alright, the distance effects, basically the exact same as the age, only this time it's affected by how far away it is from either our emitter, which we can set it to use the emitter plane, or we can just have a near and far range. And the left side is the near range and the right side is the far range. So we actually can't see it over here because our volumes basically stay in place. But the further away it gets away from our emitter, we can affect how our Pyrocluster looks. This would be useful for something like, say, a meteor, or maybe a rocket blast further away it is from the ground. You can affect the radius, luminosity, color mix, and the actual color. And they can be used together with age effects, but most of the time age will take precedence over the distance effects. Okay, let's go into cylindrical distance, which is like distance, only this time imagine an, let's say, invisible cylinder around our emitter, and the further away our particle is from that, that's what affects our radius, luminosity, color mix, and color. We can also change the emitter direction, and again edit our near and far ranges. But let's just turn that off, make sure they're all off, and let's go into shape. And for this I want to switch back to our, let's just remove unused materials, move back to our actual cloud material. It's set to sphere, but you can also change it to cylinder, box, or torus. Let's just leave it at sphere. And you can change the radius, which is really nice. So you can, in a way, affect the size of your clouds. But let's just switch that back to 42. And scroll on to bottom. Let's just skip these for a second. And let's uncheck preview. And right away, those transparent spheres that we had are gone. Preview is real nice because, especially for something like clouds, you can see where our clouds are actually going to be. You can set the maximum visible particles. Let's set that to 10. You can see most of them disappearing. Set that back to 100. Let's go back to the top. We have radius 2, which is grayed out, but if we switch it to torus, you can see we're not defining the inside of our torus. But let's just switch that back to sphere. And another setting we can use is hemisphere. I'm actually let's switch out of our camera, and we can see our spheres have been halved, and we can actually change what percent we're using. So 0% doesn't really matter that you have hemisphere switched on, but as you scroll through, you can use less and less of the sphere. But let's just switch that off. We have use particle transformation matrix and use auto rotation. For particle transformation matrix, this is real nice. So it can, based on the direction, the rotation of the particle, it can actually transform our actual puff, so it follows that. And the auto rotation, just what it says, it'll automatically rotate it. But if our particles aren't actually moving and they're just spinning in place, you're not actually gonna get an effect. It doesn't take into account the position. So make sure your particles are moving if you're going to use auto rotation. We also have rotation, which if we just mess with that, it's heading, pitch, and let's see, what is that last one? Heading, pitch, and bank. Heading, pitch, and bank. And by default for our cloud material, it's actually set to 56. You can see the angle, but we can also change the other angles. Let's set that to 90. Or, actually 90 for bank, but let's actually turn those to 0 because we actually want to keep the shape. I like the shape of the default. We also have scale, which is why our spheres don't actually look like spheres, but more like eggs. Let's actually turn down to 1 visible particle in our preview, and let's set these each to 1. And now we have a perfect sphere again. But that's not what we want for our clouds. So again, X, Y, Z, and you can control the scale on those axes. So let's just turn those up. You can see, you can really play around and really control the shape of your volume. But let's just switch that back to what they were before, 1.5, and you can switch back to 0.9, but we can keep it at 1. It's not much of a difference. And I don't actually remember what that was. I think 2.3. Let's just hit Control Z. Yeah, 2.3. Let's just set that back to 0.9. You've also got velocity scale, which the velocity on that axis will affect the shape of our particles. Since our particles are actually moving for this scene, we're not actually, we don't need it. But let's say we have a particle moving really fast and in the Z direction, and you want it to stretch in that so we can turn that up if we wanted that to happen, but we're not really using it, so let's turn that back down to 0. Alright, we already explained what preview does. Alright, switch back to our camera. We already explained what illumination is. Again, we're going to leave that off. But let's switch to shadows. And this can also really affect what our Pyrocluster is going to look like. If we just switch off received, cast, and self shadows, then our settings in our volume tracer, right here, for shadow map step size, they're not really going to do anything because we don't have any shadows to begin with. And you can see how much faster that's going to render. Let's just render that up. Again, it didn't calculate shadow maps, and it just started rendering right away. Let's actually stop that render and go back into our shadow settings. And we actually want those on. But we can also change the look of our shadows directly by changing the transparency. Switch preview on. Let's set the transparency to say something like 80%. There's basically no shadow, but again, you're going to want some transparency, but not a lot, otherwise you're not going to have shadows anyway. You can also change the actual color of our shadow. This is the color they have by default on the Pyrocluster clouds preset, and you're not really going to ever want to use pure black. Because really, you can start to really color your Pyrocluster based on the color of the shadow. So using colored shadows is really going to get you the best results. Alright, the shadow color filter, which will affect the color of the shadow based on the color of the light. So if we have, let's say, an orange, a light passing through a orange Pyrocluster, the shadow is going to be orange. We also have the use shadow map samples and the volumes, which affects how much of the volume should be searched to look for rays to generate our shadow maps. Playing with that setting can get you some less than desirable results, but if you find a middle ground, you can actually get some pretty good Pyroclusters with a faster rendering time. The ray trace samples is the exact same thing, but again with hard ray trace shadows. And we also have Darkened Capacity, which Darkened Capacity, which controls how much light to add or subtract based on the overall transparency of the Pyrocluster. So if we turn dark factor up, you can see our puff getting darker. And if we turn it to a negative number, it gets brighter. So we're subtracting less light, but we're actually not going to use that. The self-shadow options. The by default self-shadows are pretty soft, but you can control how soft or sharp you want the soft shadow with our sample range, which if we turn sample range up, we get a smoother, softer soft shadow, but of course it takes longer to render, and the bias just controls the distance between the shadow and the volume. Lastly, let's look at noise, and this is really what we're going to be editing to get that look that we want. It's it's just like basically, again, a noise shader inside a normal material. A lot of the same settings are there, like low clip, high clip. Let's just switch back to our material, Pyrocluster material. But a lot of the settings are also different. For example, regularity, which controls the crispy and smoothness of the edges. If we turn that all the way up, you're going to see our puff become really smooth. Okay, see, the edges aren't crisp or wispy at all. And it's almost taken up the entire volume. So load setting, especially for clouds, is really what we're going to be looking for. Let's turn preview back on. Alright. The grow radius controls how much our noise scales with our volume. Setting it to 100%, it'll scale almost all the way. Well, it'll scale with our noise. Let's just leave it at that. The scale controls the overall scale of our noise, and peak blend, we can control the peaks or hotspots in our noise. Detail, if we turn it all the way down, it's less detail, but it also is much faster to render. See, not a lot of detail. But let's just leave it at 5, which is the max. It'll take a little bit longer to render, but you're going to need the detail, especially for something like clouds. We've also got phase and gain. We've also got phase. which changes the angle of the noise. So actually, if you're animating something like fire from a lighter, you can animate it really quickly in between frames to get a look of it flickering, almost. We've also got gain and bias. Gain controls the noise intensity on the inside, while bias controls the noise intensity on the outside. So if we turn gain all the way up, you're going to see the inside of our puff is really, really extreme. But if you really change it slightly, you can get a crisper. For example, if we change it only slightly, our edges look a little bit more crisp. But let's just leave them at the default 50-50. Then you've got low threshold and high threshold, which are like your low and high clip inside of a noise shader. Let's just reset these to default. And finally, we're going to be using this setting, which is use color. Now we're going to be mapping our color based on the noise, which I think is a lot more useful than just mapping a gradient the inside out of our material. So if you go to noise and you turn use color on, you override the color you have set in your globals. And something like this, I have two colors saved. They're basically the same. We have one color which has barely any saturation at all, and the other color, which is going to be using the outside of our noise, again has basically no saturation, but it's a little bit more blue. To see the difference, just switch use color off and on. It's really slight, but once we render it out with all the puffs, you're going to see the difference. And also we've got static position and invert noise and no scale. Static position is going to freeze basically the noise, and then our puffs are going to move through the noise. So just kind of think of it as a single puff moving through, let's say, a bigger puff of noise, and the noise isn't moving, but our puff is basically a mask to let us see the noise. We also have no scale, again, which if we turn it on if we stop the scaling, which by default is turned on, when our puff is scaled up by what we have set in the shape values, our noise is not going to be scaled up. If we turn it off, you're going to see our edges turn real soft. There you go. And our noise is actually being scaled with our puff, which for this we're not going to want. We can also invert our noise, turn it inside out. Finally, let's set the noise type to FBM fractal, which I think it just has a wispier look to the edges of our clouds. Alright, now let's render out with our new settings and faster settings in rendering. And I have the camera set. Let's maybe get an edge, add a little bit of perspective. And let's render it. Alright, I'm going to pause the render and we'll come back, see what all our work's done for us. Alright, we're done. I'm Untitled Chapter, and thanks for watching. If there was some jumps in the video, sorry about that, but I crashed a couple times. And if you look at our render time, we cut it down to 1 minute 30 seconds, and I think our clouds look pretty good. They certainly don't look cartoony, and hope you learned something from it. Thanks for watching.